Hey, hi everyone. My name is Kunal Gautam. I work as a principal architect with one of the man companies and in the industry for 16 plus years in the domain of big data and AI. By working across 20 plus countries across the globe with 50 plus customers, one thing that I have realized is most of the people that I have interacted, especially the ones who are trying to make a domain change, example, they were part of the electrical science domain, they wanted to take a leap to computer science, or somebody coming from purely a mathematical background, they trying to take a leap. What's happening is people lack the basic, and as a result, studying computer science as a whole, and especially trying to achieve a job in this domain, looks like a humongous thing to them. So the intent would be that I will be trying to make everyone understand from the first principles how you should be learning computer science and the fundamentals around it. And it just ensures that your journey will be quite seamless, and you will realize that you don't need more than high school understanding to even build the most complicated LLM, which is the large language model on the planet. A bit about myself, that I was also a co-founder of an e-mobility startup back in Germany. I have spoken at multiple Hadoop conferences around the globe, especially being the Apache Big Data Conference in Budapest, LinuxCon Korea, Kaggle Summits in Munich, Analytical Con in Seattle, the reInvent in Las Vegas, across the 16 plus years of experience that I'm having. And the best part is because I have worked across 20 plus or 30 customers across 20 plus countries, I have stayed there. So this also gives me a very good understanding of the diverse workforce in terms of the culture, like how people tend to understand something, how people try to gaze a problem statement, and what is their approach. So I will be trying to provide a very, very holistic overview so that it doesn't matter which part of the world you belong to, you will be able to connect to it. So let's get started. For the first podcast, our agenda at a very high level, yeah, we'll try to be much more fluid, but at a very high level, the structure would be, first of all, just to understand that if you understand your own body and mind, that's where the study of computer science, or for that matter, any learning starts. Then we'll delve into our basics of computer science. We'll speak a lot about perceptions and contract. What is a serialization? We'll go for some coding examples. And if you have a Q&A, feel free to post your questions on the YouTube comments and section. So let's take a pause. And the understanding would be that even before you start on your journey of computer science or learning any subject for that matter, the idea would be take a moment, have do meditation for 5 minutes with the intent just to observe how your body and mind behaves, because this is the most critical part of it, given that all the human beings, including the one who have built computers, who have built the self-driving cars, who have built the LLM, they have a unique, let's say, capability which is present in all of us, and that's the human brain and mind. And if you start to observe how it works, you will realize that whatever you are thinking, you manifest that in a real world and you get that as an object. But all the thinking and the vision of that starts in your brain and mind. So let's start breaking this concept into small pieces, something that you can correlate. So I would just like you to take a pause for 10 seconds and just observe your mind for a moment, that as you are hearing me, what's happening? Where are you actually hearing me? Or if you touch the table which is next to you, where are you really sensing that table? Or if you are seeing this video, where is exactly you are seeing this video? Is it your eyes? Is it your brain? Is it your mind? Is it your hands? Where is that exactly? So we'll start with something very basic. Just start observing your body, and you will realize that your body has many faculties, right? So you have your hand, you have your legs, you have your internal organs, you have your brain, you have a mind. and everybody is supposed to do something very deterministically. What I mean by that is your hand knows only couple of things to do. Example, I can raise my hand, I can use my palm to grab stuff, I can have motions across like at my elbow or at my shoulder or at my wrist, but your hand only knows these specific thing to do. So the first question would be, does your hand realizes that you have a leg? Or does your hand realize that you have a body? Or does your hand realize that there is a world outside with wherein you are interacting with it? And same goes like start extrapolating this idea for each and every organ. Does your heart realize that you have a leg? Or does your heart realizes you have a brain? So if you think about it, you will realize that all of your body organs, they are all doing some predeterministic task. But overall, you as yourself, you realize that, hey, I'm a human, there is a real world to it, and I have to interact with it. So the question is, in your whole body, who is aware that there is a real world out there? Just take a pause and think about it. And the fascinating part of that is, answer is there is none. So which body part really realizes that, hey, I am a human being, I am alive, and I have a world to interact with. So definitely it cannot be the hand, legs, your kidneys, your liver, or your spine. It has to be either your brain and mind. Just take a pause to understand, are brain and mind the same or are they different? Just think about it. So you will very soon realize that your brain is just the hardware. Mind is something which is getting signals from all over your body. It's trying to create a persona of yours. It is somehow able to understand the real world. And then you are able to navigate through different situations and tasks and able to sense it and feel it, all the emotion, happiness, joy, greed, lust. You're able to get all that up. So what is basically the difference between brain and the mind then? So if you look at the Vedic philosophy, they because the whole idea in the Vedic philosophy was you go for long hours of meditation. So Vedic philosophy was just not about that, hey, I am doing something good to another human being and I will be served heaven, because that was never the idea. The idea was all about, hey, can you just observe yourself just to realize that you are something more than you perceive? And that's the reason they went ahead trying to figure out each and every emotion, like what do you feel? Why is it happening? Whatever you're feeling, is that even right or not? Or is that a perception? So that's the reason in the Vedic philosophy, the mind has multiple different, let's say, facets or layers within that. So one is known as the Manas, one is known as Chit, one is known as Chetas, the other is Hriday, and there are many more. But what I want you to appreciate the fact, your brain and mind are not the one. And again, just to provide some data points around it, when you are born, when I say you are born, like when the mating happens and a human is created, what is the first organ that's created? And the answer is it's your heart which is created the first. So it means that even without the brain, the heart is able to work. So there was something else. It's not the brain. There was something else which was powering uh, life inside you. Heart had all the capability, all the intelligence to understand how to work. So that's where the distinction between brain and mind is coming. And again, from the Vedic philosophy part of it, mind doesn't reside inside your brain. Mind is something which is inside your body as well as part of the eternal consciousness. So you can close your eyes and you can still feel and see and understand this whole world, because mind is is not just which is something present inside you. Mind is the one which what we call also as Chetana, that it realizes that you are something more than your body. All right. Although this concept looks very fascinating, just keep in mind we will tie all these concepts eventually into how computers are also following the same mechanism as it was being built, and how you can write much more optimized code, try to understand how computers work based on the same ideas. Okay, let's move forward from here. So just a couple of questions that if my hand doesn't understand that I have a leg, or if my leg doesn't understand I have a hand, or vice versa, or my organs don't understand, then it is just the mind which is able to sense everything and make an understanding around how the world exists for you. So I just want to do a very simple experimentation with you folks. So just bear with me. So now I will give you a situation, or let's say I will try to make you imagine something. With your eyes closed, just think about it. So let's say that I have a cube in my hand. Can you rotate that cube by 90 degrees and visualize how is it looking? And magically, although this cube doesn't exist, right? Like I was just doing the hand movement or gestures, but somewhere inside your brain, there is an abstract space wherein you were able to visualize that cube. You also were able to rotate that cube by 90 degrees and you were able to see it. So, what it means is inside the human brain, or rather the human mind, we have a digital replica of the whole world. And I just want you to focus on this specific concept of abstraction, something which doesn't exist, but you are somehow able to manipulate it. And whatever manipulation you do on this abstraction results into a output, and that output can be of any significance. Example, I can simulate how to drive a car in my head. And in that process, I can start learning how to drive. So here comes the most important concept, that from making babies to making a car or an aircraft or a missile, it all starts in the human brain. Once your human brain is able to come up with a logic, it's able to come up with a design of that solution in the abstract space, you are able to manifest, or let's say reflect that in the real world. The second very important concept I want you to appreciate is, let's say you touch another human being. So you're going ahead, you are meeting somebody or you're greeting somebody, and you are just doing a handshake with them, or you are trying to touch a table, or for that matter, you are trying to kiss someone. So the question is, where are you feeling all these senses? Are you really feeling the other human being? Just think about it. Even like whatever you are seeing on the screen, are you really seeing that? Or the signals are being gathered through the different senses that we have, be it your smell, be it the skin, which is getting this perception that I'm touching someone. Those signals goes back to your mind. Your mind interprets them, and that's how you are able to feel it. So what it simply translates is doesn't matter what you do, you are just experiencing your own self. There is no capability, or fundamentally, there is no organ in your body which has any capacity to even touch, feel, sense the external world the way it is. And that's where I'm emphasizing feeling something the way it is versus you are just feeling yourself. Example, I was touching a table. I can touch the table with the senses that with whatever the sensors I have on my skin. Let's say if I burn this part of my finger and I try to touch the same table, I will not be able to feel it. Rather, I will be having a burning sensation. So it means that I was never able to touch the table. I was always able to feel the senses, or let's say the signals that was being generated by the tip of my finger. So that's another very fascinating fact, that as a human being, although we crave for love, we crave for appreciation, we crave for all the different emotion, but end of the day, it's next to impossible even to understand how the outer world looks like, because it's just us experiencing our own selves. So that's something very fascinating, I would say. So two great concepts out from here. First of all, or rather three, I would say, each and every human part or faculty, it's working on its own in a predeterministic format. Your legs cannot be used to fly. Your hands, you can have certain motions, but you cannot fly leveraging your hand. So each and every body part has a certain functionality. No two body parts understand what they are doing, and somehow human body as a whole is able to experience life, and you are able to form bonds, you are able to replicate, reproduce, jealousy, war, you're able to create all these things, although no two body parts are even aware that, as a system, this is what we are doing. So that's so fascinating. Second part is, apart from your mind, there is nothing in your human body which can correlate all this to get something done, to experience something. This is the second part of it. And the third part of it is the concept of abstraction, that there might be something visible to you. It is somehow getting abstracted in your head in a certain shape or form. You interact with that abstraction and you manifest that abstraction in the external world. And that's how you interact with the world outside. So, with this thought, although I feel that this is quite philosophical, but just keep in mind, this is the basic idea to learn any let's say subject, and especially with computers, because in computers what you will see is this idea of abstraction, this idea that each and every entity was independent, not aware of what other does. It just grows and multiplies as the solutions are evolving and becoming more and more complex. So that's the reason I really wanted everyone to appreciate this fact about their own body to begin with. Another interesting fact before I forget, that the human mind is the only, let's say, the faculty which can disassociate itself with the boundaries of your hardware, which is like your muscles, bone, organs, and can think something beyond that. Because your hand, no matter how much you try, no matter how much gym you go, you can never develop your hand to fly, because it is limited by the hardware capability that the hand has, like the way God has made our hands. But your mind is something you can, like, you can really go ahead, you can disassociate, thinking that, I am not associated with this body, and I can still imagine, think, manifest something completely out of the blue. So that's the beauty of the mind. Probably there is nothing, something which can be replicated in the computer science world as of today, because computer science, or the computers as such, they get limited by the hardware components there. They cannot do anything beyond that. Great. Let's keep moving ahead into some more fascination now. So, the other concept comes as perception. What is reality versus what we perceive, and what is the outcome? So, let's look at this interesting fact, that we all are sitting here, we are having this discussion. Just keep in mind, as we sit at this point in time on the planet Earth, we are moving at a speed of 1670 kilometer per hour around the axis of the Earth, right? The Earth itself is orbiting around the Sun at 67,000 miles per hour. The Sun is moving across the Milky Way galaxy at a speed of 514,000 miles per hour. And the Milky Way is expanding in the space at a speed, cumulative speed of 2 million kilometers per hour. How fascinating is it that although we all are moving at a speed of 2 million kilometers per hour, we all look around and we feel everything is static. Like we feel that this table, chair, the trees outside, the birds outside, everything is static. In reality, everybody is moving with a speed of 2 million kilometers per hour. Just imagine the kind of speed we are moving at. But the world seems to be so static to us. Just take a pause for the moment just to appreciate this magic that's going around. And but the body makes us perceive that we all are super static. And the reason, and the scientific reason being, everybody is moving at a 2 million kilometer per hour. And when you see each other, you see that, hey, there is no movement across both of you, because whatever, when I say both of you, you and the article which is placed next to you. But that's so fascinating, because if we make an instrument which somehow makes you to revolve at 2 billion kilometer per hour, probably you will not be able to take that much of rotation, and maybe you will fade or become unconscious. So again, the idea, perception, what our mind is making us to believe versus what's the reality, that's huge different. Try connecting to the connecting it to computer science. Whatever we are doing with the computers within the CPU is working at a different, let's say, abstraction layer, different completely. But what we get to see as an output is something which is useful to human beings. To the CPU, it is not even making any sense altogether. So again, the whole idea, who is perceiving what at different layers, is completely changing. Adding another data point to it, let's look at the human eye. So I'm able to see this amazing world, the different colors, the beauty of life, the beauty of the things around us. But let's imagine for a moment that the human eye was able to see electrons, protons, and neutrons. Just think for a moment what you would be seeing around you if that was a possibility. Would you be seeing this laptop? Would you be seeing this YouTube video? Would you be able to see a house, even your parents, your siblings, your partners, your wife, your girlfriend, boyfriend? Would you be even seeing anybody? The answer is no. You would not be seeing anything, because it will be just electron, proton, and neutron, which are just moving across each other, which is so fascinating to begin with. Secondly, we all are aware the electron, proton, and neutron, which is present in the table, is the same electron, proton, neutron, which is present inside you. And it is the same electron, proton, neutron, which is present inside the table, or sorry, the wall that you are, or the ceiling, or the roof, or the ground that you're working with, or even with the trees. And all those electron, proton, neutrons, they are jumping from one element to the other, because end of the day, it is exactly the same. So in this world wherein you can see the electron, proton, and neutrons, it would be just a massive exchange, or let's say a free flow of electron, proton, neutrons just moving across everywhere. And there would be no physical identity that you will be able to distinguish, saying that, this is Kunal, this is Anna, this is Robin, this is Atul, blah, blah, blah. So that's again the perception. The world that you see, is it really there? Or is it a perception or an illusion, as you say in Vedic science? That it's a illusion that's has happened in our head. What's really going on? So with this, I would request you to take a pause, think about it. And the idea would be, if you want to accelerate your journey in computer science, it's very much needed that you go ahead and meditate and observe yourself. Because more you are doing it, it will be much, much, much easier to translate the same ideas and concept to computer science and accelerate your journey of learning it. All right. So now moving on to the next part, the basics of computer science. That, hey, all these ideas are great. How do I correlate this to a computer now? So end of the day, start now matching the ideas with whatever we have described. So just like a human body had hands, legs, heart, kidney, blah, blah, blah. A computer has only four different, or let's say at a high level, four different components. And the components are CPU, RAM, hard disk, and network card. The rest of the things that you see are, let's say, are the periphery or the accessories that you attach to them. But these are the four components. In the Amazon world, a computer is known as EC2, Elastic Cloud Compute. Maybe your laptop also represents the same. Yeah. And I just want you to appreciate the fact, especially for all the viewers who use Windows laptop. Just keep in mind, a Windows laptop in terms of hardware is no different as compared to that of a Linux laptop. And it's no different as compared to a Mac laptop. And it's no different as compared to a Lenovo or a HP laptop. It's exactly the same. The hardware components don't change. What's changing is the look and the feel and the UI and the packaging. So now let's for the viewers who are starting from very basic, I will just give like a one-line introduction for all these different components. And as we move forward in the session, we will go for a deep dive into each of it. So first of all, the hard disk is the one wherein your data is stored permanently. What I mean by that is, even if you turn or switch off your computer, your data will be stored there um, forever. Let's keep it very simple. Until unless you go and delete your data from your hard disk. Example, if I store a file or I install a software, and especially I'm trying my level best to understand the folks who are coming from the Windows world, what's exactly happening. Because the idea or the intent would be take any example that you're doing on Windows, or let's say that take a task that you are doing on Windows and try to see that which component you are impacting or you're interacting with. So let's say I have a file, I want to save it. If you're saving a file, what do you mean by saving a file? It simply means that that file goes and resides on your hard disk so that even if you switch off your computer, the data or the file is not removed from there. If you want to connect your computer to the network card, to the uh, internet or to your Wi-Fi, you require something known as the network interface card, NIC. And that's the hardware through which either you plug in or you have a Wi-Fi to connect your computer to. Your RAM is the place which is again it works. It's pretty much similar to your hard disk, but it works at a much more faster pace. And secondly, the RAM has ephemeral memory. What I mean by that is, if you switch off your computer, the data in the RAM goes away. So anything that has to be persistent cannot be on RAM. And then you have your CPU, which is your central processing unit, which again has multiple layers, but at a high layer, a high understanding, this is the place where all your computation happens. Just keep in mind, CPU in itself is a hardware component. It's made up of hardware. It's not a software that is present inside it. So let's look at, and again, as we move ahead from here, and for rest of the session, the idea would be we have to start getting very precise and concise about each and everything that we say and articulate. So now let's start talking about the units. So if you want to buy a CPU, the unit of that CPU is how many instructions per second you can execute. That's known as the gigahertz per second, because a CPU comprises of multiple hardware components inside. And the whole idea is, hey, CPU, how many instructions can you execute per second to accomplish my task? A RAM is given by what is the size of the RAM? Like it's a 12 gigs RAM, it's 18 gig RAM. Just keep in mind, RAM, although has the storage part, which is ephemeral storage, there is also a parameter for the I/O. How many bytes I'm able to transfer in and out of it. And that's very, very high as compared to that of a hard disk. The disk has terabytes of storage, and at the same time, you are also uh, able to read and write to the disk. So the disk again has two components. One is the storage, and the other part is the amount of data or the I/O input output that you can do with the disk. It's represented as whatever 100 megabytes per second. Network card is the one wherein either the data can come from the internet, go to your laptop or a computer, and vice versa. That's why the network card is always represented with a unit of megabits per second. Network card cannot store any data. Clear? So what will happen is just keep this in mind, because end of the day, whatever we do with the computer, we just need to understand what's happening. If we are interacting with the computer, what is the resource we are interacting with? So let's quickly look at the CPU to begin with. So this is how a CPU looks like, and just keep in mind inside the CPU you have hardware components, which is like, let's say, at a very low layer, it's mostly capacitors and transistor and resistor. And just keep in mind these are the actual hardware components which are present inside the CPU, and there are millions of it. So the question is, if it is all hardware, how are all these logics getting processed? So I will try to provide a mental model. Try to think about it. And the mental model is, you have a fan in your house, or you have an air conditioner in your house. You have a switch. You switch on and the air condition starts automatically. You switch off and the air condition shuts down. Is there any logic associated to it? Answer is no. And the reason being, it's hardwired. If you just pass on current, it will automatically start. If you switch off the current, it will automatically stop. There is no logic associated to it. So what has been done is, and again, there are great materials out there. You can do Google search about how different operations are done on the CPU. And when I say the operations, we'll very shortly get into that. But the idea would be, what operations are we doing? So CPU says that, hey, whosoever is creating the CPU, maybe it's ARM, maybe it's Intel, they say that I have created a CPU, and the CPU can perform only, let's say, 500 instructions. And you have to build everything on top of the instructions that they have provided. Because just keep in mind, those instructions are hardwired by creating logics like this, or let's say the transistor and capacitor. This is a adder, like a small electronic, uh, let's say a small electronic jumbling of the different components to get addition done. So just keep in mind, there is no logic. Like, if you pass A and B as 0 and 1, you will start seeing whatever sum and carry as some output here. It itself doesn't, it itself is not aware it's doing addition. It is only we are perceiving it. Just think about it. It's pretty much like the human body. That, hey, I am doing something, but it's only your mind which is knowing it. Your hands are not aware that I am getting a work done in the real life, in the real world rather. So similarly, this is also hardwired. You pass some electrical signals and you get back some output from here. There is nothing the CPU is aware of, that it is doing an AND operation or a OR operation or an addition operation or a subtraction operation. That is something you are perceiving. So I will quickly show you, like, this is one of the microprocessors, and you can see here, this is the instruction set. And again, it says that, what kind of instruction I support, or let's say what kind of instruction is hardwired. Is add, and is there, and you can see here, it's pretty much doing the and operation. And what is the mathematical abstract concept? We'll get to it shortly. But from the image, you must be having some idea, like what's happening here. Similarly, it supports multiple other instruction. But just keep in mind, this is the only instruction set which the CPU can understand. It cannot do anything beyond this. So that's fascinating. So it simply means that somehow the CPU has abstracted, or the CPU is trying to replicate some abstraction. So just take a pause and think about it. What is the abstraction that CPU is trying to replicate, in the sense that if I am able to somehow map those abstraction in form of a hardware, I can pretty much do all the tasks a human can do. And that mathematical abstraction was known as the set theory. So all the operators that you have in set theory, plus more instructions, like more operators that were there, it is all part of your CPU. So CPU is nothing but a manifestation of the abstract concept of set theory, because if you think about it, set theory forms the basis of all the analytics that one can achieve. Think about it, because all the people who are aware of SQL, you do joins, you do group bys, you do a Cartesian product, that's exactly the operators of the set theory. Just think about it, how it all ties up now. And CPU is the physical manifestation of the abstract concept of set theory. And that's the reason from a high level language like Python, Java, instruction somehow flows down to the CPU. CPU is hardwired, it gets the work done, it gets you an output. The only beauty of that is the input and the output only humans can make a sense of. Neither the CPU, neither the hard disk, neither the RAM, they are aware of it. That's the beauty. All right. Now, quickly, another concept I want you to understand, that CPUs are binary in nature. Why do we say that they are binary in nature? So the first thing you have to understand is all these hardware components, uh, they respond to, let's say, plus 5 volts and plus 10 volt. Or let's say a capacitor can be charged and discharged. So it can only maintain two states, one, zero. Just keep in mind, zero doesn't mean that there's no power. It simply means that plus 5 and plus 5 minus 5, or sorry, plus 5 and plus 10 volts. So based on the fluctuation of the voltage, it tries to make some sense out of that. And again, sense by the human beings, internally, it just responds to it. That, hey, this is a signal. And if I get a signal plus 10, some electrical wiring, or let's say some electrical components would be triggered. And this is the output that you will see. All right. So now, another beautiful concept that I want you folks to understand, that what has happened is number systems were created, and CPU works with 1 and 0, and that's the reason you have the base 2 number system. So again, this again goes back to the idea that even when the humans were creating the number system, who is aware of the numbers in itself is the human. And let's try to have a deep dive, or maybe at a very high level, the understanding around that. So let's say a base 2 number system is there. What it means is there are two symbols, unique symbols that will be there, namely 0 and 1. And just keep in mind, 0 and 1 were just symbols. There is no logical meaning attached to it. It's only the human brain which thinks that 1 is greater than 0. Let's take a decimal number system, as in like when you are doing a counting, the human counting of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. So in the decimal 10 number system, you had 10 unique symbols, and which was denoted as whatever 0, 1, 2, 3, 4, 5, right? There is no context like, 6 is more than 5. It is only the human brain, because we have been taught that way, that we realize that this symbol 6 is more than 5. The symbol 5 is more than 4. It's only us who realize that. In the number system in itself, these are just unique numbers. And just look at the sequence. You start with 0, you reach till the 10th element, which is 9 here. And post that, you start repeating again from 0. So what happens is 9, then 10, 11, 12, 13, 15, 19, and then 20. If you look at the decimal binary number system, it's 0001. All the symbols are exhausted. So you start with 1011. All the symbols are exhausted. So it starts with 100. So are you able to appreciate the beauty that if I was able to create any hardware, or let's say any abstraction which can work with the idea of the number system, as in like ability to understand the uniqueness of the symbol and get something done out of it. I can replicate that to do addition, subtraction, multiplication, division. And that's how the CPU came into being. All right. Uh, I would just love to take a moment for you to appreciate this fact that whenever you are, let's say, interacting, and especially for the people who are using Windows, you are opening a browser, you are writing a Python code, you are writing a Java code. Just keep in mind, whatever code that you write, you are not interacting with with the hardware end of the day. There is an operating system in between. So your Java code is taken as an input to the JVM. Your JVM interacts with the OS, and the OS interacts with the hardware. And again, anything that you're interacting with, it cannot be residing only on the hard disk. It has to be there on the RAM. And the reason being, CPU is working at such a fast pace, it has to interact with the RAM to get the work done, because RAM and CPU pretty much have the same bandwidth. Hard disk is working at a very slower pace. So start correlating. On a Windows machine, if you go and click on a Outlook, what's happening? What's happening internally is from the hard disk, the files are getting loaded onto the RAM. Because it is getting loaded into the RAM, it goes onto the CPU. You get the CPU cycles, and it becomes responsive to you. But do not assume that CPU internally understands the UI, or CPU has an understanding what is the code out there, because CPU internally has no understanding that it's a browser or a file or a Python program, because CPU only knows it's a predefined hardware wherein the data will just come, or let's say 1010 signals will come, it will get executed automatically. Your hard disk is the one which just understand how to write like how to say 1010. It has no idea about that it's a Python program or a Java program. So that's the beauty. The beauty is only the UI interface that you're using, whatever output that you are getting, you are able to understand or interpret what is happening there. Internally, none of the systems are able to. Secondly, just keep in mind when you are browsing a file system in your Windows machine, there is nothing like, there's a box, inside that box, there's a subfolder, blah, 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 at the hard disk level. Because hard disk has no understanding around that this is a folder, this is a file, this is blah, 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 whatever that is. For it, everything is a byte. Only in the UI, you get a perception that I am browsing through. In reality, at the CPU level, there is nothing of that sort. So again, just going back, just trying to wrap up for the first session, that everything is working in its own idea. CPU has no understanding about the RAM. RAM has no understanding about the hardware. Your OS UI has no understanding about how things are working. Though it's all abstracted out as a hardware machine or in the form of CPU, which understands binary data because it's hardwired like that to get some work done. It's an abstraction. And the output of the abstraction comes to you, or you perceive that you are able to get the work done from your computer. Just think about it, because your human brain is working exactly on the same lines. So with this session, I would like to take a pause, think about it, and then we meet for the next session with a better deep dive and understanding around the contract serialization and some code deep dive. Do provide your feedback about how did you like the session, what you would love to understand, or what was not good. so that I can modify my way of explanation in order to or rather to ensure that you are able to get this consent. The last thing from my end would be computer science is just like mathematics. You have to understand and you have to practice. If you are not practicing it, it will be very difficult to have the conviction when you speak in front of people or while even trying to solve a problem. So just keep in mind, keep like first of all, it's very basic. You don't need a logic more than a high school student in order to learn the most complicated concepts of computer science. But at the same time, keep learning, keep practicing, and keep growing from there. Thanks a lot, and see you in the next session.